In this class, I'm going to discuss about the Markov chain and Markov process by some examples. Let me take the first example. Suppose a transition matrix of a Markov chain Xn is given as P, and the initial distribution probability is given as P naught. Then how can we find probability of x2 equal to 3 and the probability of x3 equal to 2, x2 equal to 3, x1 equal to 3, and x0 equal to 2. So let us solve this. So let first of all we can find probability x2 equal to 3. Here you understand that x2 means it is step 2. So in order to find the probability x2 equal to 3, we will find p2. We will find p square. So p is already given, and so we will find p2. So p2 is nothing but p into p. If we find the product of this thing, this p two times, we will get here 0.43, 0.31, and 0.26, 0.24, 0.42, 0.34, and then 0.36, 0.35, and 0.2. So this will be my P2. This will be my P2. Okay. Now after second step, my transition probability will be this. Okay. So now in order to find the probability of x2 equal to 3, I rewrite that one in the form x2 equal to 3 given x0 equal to I, where I is the present state. So this is equivalent to saying summation. So I can write this one as I can probability x2 equal to 3. We can write in this way summation I probability of x2 equal to 3 given x0 equal to I into probability of x0 equal to I. Okay, so where I is the state, here it is given I0, so I p0 equal to 0.7, 0.2, 0.1. Now this will be equal to, if I expand it, what I will get, say like I equal to 1. I equal to 1 means I will have probability x2 equal to 3 given x0 equal to 1 into probability x0 equal to 1 plus probability x2 equal to 3 given x0 equal to 2 into probability of x0 equal to 2 plus probability x3 x3 x2 equal to 3 given x0 equal to 3 into probability of x0 equal to 2. Now we know this is nothing but ai to aj means 1 2 3. So we denote it as p13 in step 2, p13 in step 2, and this is nothing but probability of x0 equal to 1 plus this one will be nothing but x0 2 2 3. So I will write in the second step p23 into probability of x0 equal to 2 and plus p in the second step, this one will be p33 into probability of x0 equal to x0 equal to 3. Now x0 equal to 1 means we will see the first element in P0. X0 equal to 2 means we will see second element in P0. And x0 equal to 3 means we will see third element in P0. And so finally what we will get? P13 in step 2. P13 in step 2 is 20.26. So we can have here 0.26 into 13 is nothing but 0.7 plus 23 in the second step. 23 23 is 0.34. So we can have 0.34 into 0.2, and then we can have the second one is third one is P33. P33 is 0.29 into x0 equal to 3 is equal to 0.2. So if we simplify it, we will get 0.27. This one will be the answer for the first question. And for the second question, we can have like this. So second question is, in order to solve the second question, what we will do is, first we will find probability of x1 equal to 3 given x0 equal to 2, and that will be nothing but P23. So in the initial TPM, P23 P23 is 0.2. So that means we will have 0.2. We'll have 0.2. Now, next what I will do after finding this one, I will find probability of x1 equal to 3 and x0 equal to 2. So that is equivalent to saying probability x1 equal to 3 given x0 equal to 2 into probability into probability of x0 equal to 2. So here we can have that one will be nothing but P23. So we will have P23 into probability of x0 equal to probability of x0 equal to 2. So P23 in the initial TPM is 0.2. P23 is 0.2, and here x0 equal to 2 is 0.2. And so we can have 0.2 into 0.2. So we will have 0.04. Next, what I will do, probability of x2 equal to 3, x1 equal to 3, and x0 equal to 2. We can write this one as probability x2 equal to 3 given x1 equal to 3, x0 equal to 2 into probability of x1 equal to 3, x0 equal to 2. But already we have got x1 equal to 3, x2 equal to 2 is nothing but 0.4, and this is equivalent to saying, since here x, the Markov chain says that it does not depend upon the past but depends upon the present, giving the present value. So this one we can read it as probability of x2 equal to 3 given x1 equal to 3, x1 equal to 3 into this value is nothing but 0.04, 0.04, because we have got the value of this one here 0.04. 0.04. And so finally we will have this one. This is P33. So we can have this one as P33 into 0.04. Okay. So P33 0.04. The P33 in the initial transition matrix is nothing but 0.3. And so we can get here, we can get here 0.3 into 0.04, and so we will get 0.012. So this is the value of the second thing. And then finally we will find probability x3 equal to x3 equal to 2, x2 equal to 3, x1 equal to 3, x0 equal to 2. That is equivalent to saying probability x3 equal to 2 given x2 equal to 3, x1 equal to 3, and x0 equal to 2. x0 equal to 2 into probability of x2 equal to 3, x1 equal to 3, x0 equal to, but we know the value of this one. This is nothing but 0.012, and so this we can rewrite as, so here this state depends upon only one state x2, and so we will have probability x3 equal to 2 given x2 equal to 3 into the value of that one is nothing but 0.012, and so it is equal to state 3 to state 2. So we can have P32 P32 into 0.012. So finally we will get P32. P32 is nothing but 4.4, and so we'll have here 0.4 into 0.012, and so when we multiply it we will get 0.004. So this is the answer for the second question. Then let me take another example. Let me take another example. Example 2. In the example 2 is saying a man either drives a car or catches a train to go to office each day. He never goes 2 days in a row by train, but if he drives one day, then next day he is just as likely to drive again as he is to travel by train. Now suppose that on the first day of the week the man tosses a pair dice and drove to work. If and only if 6 appear, find the probability that he takes a train on the third day and the probability that drives to work in the long run. So what is the thing here? Here we are having two states. So the states are the travel pattern. So we are having two states space. The state space are by train and by car. So these are the two state space. Okay. And then what will be my TPMP? TPM is, let us go to the question here. What is the question? You see that he, if he travel by car in first day, he will likely travel by car, but he conjugatively cannot travel 2 days by train. So suppose here presently he travel by train and then car, train and car. Now what happens? So in the first day, if we travel by train, so this is my x n minus 1, this is my xn, this is my present state, and this is my future state. So now if the first day he travel by train, then there is no chance that he will again travel by train, so that is 0. If he travel by train in the first day, there is a chance that he will travel by car, and so we will have here 1. Similarly, in the first day, he will travel by car, then there is a equally likely chance that he may travel by car or travel by train. So if he travel by car, then there is a chance that he may travel by train or he may travel by car, but both of them are equally likely, so the probability will be half in each case. Okay, so this is my ppm. Now what will be my initial probability? So we know that he tossed a pair dice. So we have 6 faces in a dice, and if it is a pair dice, the probability of outcome of each face are equal. So what he is doing, if so here I will have probability P traveling by car by car is nothing but probability of getting 6 in the toss of die. In the toss of die, and so that is nothing but 1 by 6. Then probability traveling by train by train is equal to 5 by 6. So my initial probability here will be nothing but P1 is traveling by train is 5 by 6 and traveling by car is 1 by 6. So this is my initial probability. This is my initial probability. Now what I will do is, what is the question is saying, what is the probability that he takes a train on the third day? So he takes a train on the third day. We want to find that one. So in order to find that one, what I am going to find is, I will first find P2. P2 means P1 into the TPM. P1 into the TPM. So if I multiply P1 with the TPM, 5 by 6, 1 by 6, and then here 0, 1, 1 by 2, 1 by 2, and we will get it as 1 by 12 and 11 by 12. And similarly, third day means I will find a third step. So P3. P3 will be nothing but P2 into capital P. So P2 you know 1 by 12, 11 by 12 into 0, 1, 1 by 2, 1 by 2, and that is equal to 11 by 12 and 11 by 24, 11 by 24 and 13 by 24. Okay, so probability traveling by train on the third day. So this will give you probability traveling by train on third day. Third day is equal to, so that will be after third step, probably traveling by train is the first component of the, so this will be the thing, so that will be 11 by 24. 11 by 24. Now let us go for the second question. The probability that the driver drives to work in the long run. So this is second state of the second statement of the theorems, that is second theorem. What he says, long run. So if we have the long run, it will approach us to a steady probability, steady state probability. And so what we will consider, let phi equal to phi 1, phi 2. Okay, so this is the steady state probability. Then in the in the long run, we can have we can have pi into capital P will be nothing but pi, and so that implies pi 1, pi 2 to 0, 1, 1 by 2, 1 by 2 is equal to pi 1, pi 1, pi 2. So if you simplify it, we will get we will get pi 2 by 2 equal to pi 1, and pi 1 plus pi 2 pi 2 by 2 equal to pi. If we solve these two equations, we can get, if we solve these two equations with the condition pi 1 plus pi 2 equal to 1, we get pi 1 equal to 1 by 3 and pi 2 equal to 2 by 4. So traveling therefore therefore probability, the main travel by car in long run is equal to pi 2. Pi 2 is nothing but 2 by